Okay, I think we're live. See if anybody's here today.
We'll see. So I'm still on the road. That's why I have a different background, and my camera might be a little bit shaky sometimes. But let's see how the connection holds up.
Yes. Yeah. So this is, I think, the final Q&A. We don't seem to get many more questions. So I think just by that, I think we'll have to call it quits.
Yeah. We also don't have new content in the book today because we are just finishing up copy editing and everything with all the iOS, the new iOS 17 changes and stuff like that.
I think by now, as we speak, maybe the final edits are being made, and I think it should be done. So that means we can do the final typesetting of the print and the digital book, and then we can release it.
Yeah.
Just on time.
That's the plan.
Maybe. Yeah. And so the last things that we did was basically a really hard push, or not a really hard push, but we pushed to integrate all of the iOS 17 stuff into the regular chapters, and that took a little bit of effort because it changes the narrative of the chapter. So some things didn't really flow anymore, and we wanted to take care to distinguish, right, between the iOS 17 only stuff and sort of the existing stuff, and so that people can read the book regardless of what platform they target.
Yeah, and in a few chapters, it's you have all these things that are basically new and are replacements of the existing things, and they're for the time being, it's we have both in there, of course, because almost everybody has to support or has to use the old APIs for the time being, but the new ones are also good to know about, and so we have both in there and try to make it not too confusing.
Yeah, I think the biggest two chapters were state and animations. So in state, there's this whole new observable stuff, which is the future, but we cannot use it if we're not targeting iOS 17 or if we also need to include all the platforms. So that's like the big thing there. And with animations, it's just a whole lot of stuff that got added, right? Like the transaction stuff that changed a little bit, just the APIs, and then there was the phase animators and the keyframe animations, and what else? Completion handlers, all kinds of stuff.
Yeah, exactly. Mm-hmm. And these most of these changes are additive, so that's a little bit easier because they don't replace existing things apart from the transition API. But in the state chapter, of course, that's a little bit more messy since everything has changed with regard to object observation. So so then these were the last changes we made to the book, and so it should be out sometime next week.
Yes.
In its final form.
Yes. So we have two open questions. So one, maybe we can start with the latest question from Christian. Let me open that up. And so the question is, well, not really phrased as a question, but the question is, how do we get good-looking working form views that work on both iOS and macOS without having two distinct views and without cluttering the view code? And then so especially forms with sections, picker, and buttons. Do you have any idea about that?
Well, I think so. One thing you can always do, which you probably will do anyway in views like that tend to grow large, is to just break them up into pieces, and then perhaps you can reuse these pieces in different ways, right? So you might have an iOS version of the view that uses sections, but macOS doesn't, but you still use the same contents, and you can, if you break them up into separate views or just in computed properties or however you want to do that, then you should be able to reuse a bunch of stuff. And so that would be one way to and how you break them up really depends, right? What you want to do, how you want to distinguish between the platforms. But that would be one way to make things reusable without duplicating too much code.
Yeah, I think the other big part is pushing as much of the maybe like the validation stuff and all of that into your model layer, or maybe you call it differently, like a view model layer or whatever. But also, I think it will be hard. Like ultimately, these are two different platforms, and I think I don't know who said this the other day, but the nice thing about SwiftUI is sort of that you can use the same techniques to develop for both platforms, but ultimately you will build separate apps probably if you want to make it feel native to the platform. And so I think for most components and views and screens, it's an illusion that we can write it once and run it on both platforms. But instead, you want to, like, the knowledge you have to build apps, you can reuse. And definitely you could reuse specific components or animations, all of that. But ultimately, they will work differently on each platform. And so I don't really believe personally in this idea where you write one app that works for all of the platforms. Like yeah, it'd be nice, but
it's probably messy. Yeah, but you could also have, so if you don't have two really separate apps, but they still share, they have a lot of overlap, you can also decide where you're going to put your ifs, basically, right, in your code.
yes.
And you could have for example, you could write your own, let's say you have some sort of a form page, and the settings that are on this form are in the end the same, but they look very different on iOS and macOS. They are layouted very different. They perhaps even use different controls. So perhaps you could write your own abstraction for some sort of a form entry or some sort of a form section or whatever, and that is kind of abstract, and which you can configure from the outside, what should be on there, but all the if statements basically to distinguish between the platforms could be in there in this abstraction, and then you could use this. But yeah, that really depends on the specifics of the situation. But yeah, maybe that could be a way to hide them a little bit, or to avoid having too many of these if statements.
Yeah, maybe this, I mean, we have abstractions like that already. It's, for example, a button in SwiftUI is just, the button with a label and an action, and that's it. And then the platforms take care of like creating an NS button or a UI button or what have you, or maybe something native to SwiftUI. And it's the same with other things like a list. I don't know exactly, but I'm pretty sure it still will translate to a UI table view on iOS, and I don't know what it translates to on macOS, but that's another way there's one way to build that abstraction. So your form could be pretty basic, and then you use the environment to tell like the form components what platform you're on and how they should render by default and all of that.
Yeah, either that or you just bake it in. Into the component. Yeah.
Yes. And so there's another question. I hope this helps about frame min height and max height. So basically about flexible frames. So the question is there something that can be said about these APIs regarding the specific use cases? I'm actually share my screen here. And what solutions do they provide that other APIs in SwiftUI do not? Sometimes I find them confusing and not able to apply them effectively. And the way they understand is that, and then there's some code.
Yeah. So I tried to parse that code. And for me, it's always a little bit difficult to parse out these min-max, nested min-max statements. But I think what we have here is correct as far as I read it. And but yeah, it's not super helpful in practice. And we also find in our work that we don't use flexible frames a lot with anything else but 0 and infinity, right? Or let's say that's the most common use case.
Yeah, let me pull this up actually.
Yes.
So here we have this section, and we explain it a little bit, but as you mentioned, we use this a lot, where basically we want to make sure that the view becomes the proposed size. And this version with the min with 0 max with infinity is even more precise, because this could be wider than proposed, and this will always become exactly proposed. And I always have to think, like, I don't remember how we implemented that. So we did implement all of the views and modifiers, or not all of them, a lot of the views and the modifiers in SwiftUI. And we did it in a Swift Talk series. And here's the code that we wrote. So back then we didn't have proposed view size yet, so we made our own proposed size. And this is how we did that. Like we first took the proposed width and otherwise substituted with the ideal width. And then for the min, this is sort of the thing going in. This is the width. So if there's a min width, and if the minimum is larger than the proposed width, then the proposed width is set. And then we propose that. And finally, after the proposing is the second pass, where we take the result width and again take the minimum, the maximum of her min width, and then this expression, so the minimum of the result width and the proposed width. And the way we wrote this, like, a little bit made sense. And then at some point we just started fuzz testing a lot of stuff, like proposing all kinds of different sizes and all of that. And I'm like 99% sure that this is exactly how it works. I'm also pretty sure that they wrote this in a much shorter, nicer way, but maybe not.
So, but it's definitely also, when you look at this code, it's definitely super confusing, and it's not immediately obvious what you are supposed to do with that in practice, I'd say. And so I think in practice there are really three things you might want to do with that. The one is this frame max width infinity pattern, which says become as wide as possible, basically. But it could also be, if you just write max width infinity, it could also become wider than the proposed width. So that could happen. I'm just saying width now, the same applies for the height. And then you have the second pattern with min width 0 and max width infinity, which says become exactly the proposed width. So that is super useful. And then sometimes, not that often, but sometimes you can just use them if you really have specific numbers in front of you. So you want this to be at least 30 points. Then you can just say min width 30 points. And so the way I always remember that is that, so if you write, let's say minimum 30, maximum 100, then this will definitely become not narrower than 30 and not wider than 100. But it gets clamped to these numbers. If you omit one of them, let's say we only specify the minimum, then it will become anything between the minimum and the width of the child. And if you omit the minimum, then it will become anything between the width of the child and the maximum specified.
Yeah.
That's basically kind of always the missing part gets substituted with the child width. And but yeah, so I think in practice, it's really, you either have these use cases where it's pretty obvious, you just have a number that you can really specify, and then it does basically just what you would expect, that this is getting clamped to this number. And then you have these more obscure patterns, like this 0 infinity stuff. But once you use that a few times, it also becomes pretty much second nature.
Yes. The other thing that this API has, if you also pull it up here, is the ideal width and the ideal height, and that like we hardly ever use those, but that can be useful if you're writing custom views that need to respond well to fixed size or that need to work well in scroll views. So scroll views will also propose nil for the direction that they're scrolling in, because the view can then become its ideal height. For example, if you have a vertical scroll view. And so that can be useful there as well. Again, if you would provide a minimum width, that would also take care of that. But the ideal width is used specifically in the case where you have a nil proposal.
Yeah.
And here, this is pretty new. Mm-hmm. So there is actually some documentation now. So here's what happens when you only specify the minimum frame, and this is, I think, the most important phrase. So if both constraints are specified, the frame unconditionally adopts the size proposed for it and clump to the constraints. So if these constraints are 0 and infinity, it literally will always be exactly the proposed size, or the proposed size for that dimension. So I think that's it's a very welcome addition that this is now documented, and definitely will keep working like that. Yeah. And like I only think of min with 0, max with infinity, or just max with infinity. Like the other parts, I don't even think about, like different kinds of values. I just, it's too difficult for me to understand when I'm coding.
It seems to be very rare that it's useful in a way, right? Yeah, but that's a good point. This is a good addition here, this description of this API.
Yes.
Yeah.
Okay.
Okay.
I don't think we got more questions. Maybe there's no live questions. This is we had a look at this question a whole while ago, and we still need to maybe look at updating this in the book. But we covered this a few Q&As earlier.
Yeah.
Awesome.
Okay.
Okay.
Did you look at the chat if there's something there?
There's nothing there. Oh, Nick is there. When could you max with infinity give an undesirable result? Assuming desired result is usually to fill all available with. Yeah, so if you...
Can you repeat what the question is? I didn't get that.
Yeah, sorry. When could only max with infinity to no min width give undesirable results? Assuming the desired result is usually to fill all available with. So I think if you have, let's say, a text, and then you do a frame max with infinity and then a background blue, that will make the text as wide as the screen. But now if you apply fixed size, then the text will become wider, and the frame max with infinity can also become wider, and so your background might be stretched beyond the screen. And if that's not something you want, you can do a min with 0. So let me actually see if we can code this up quickly. Give me a second here. Okay, so I think if we have like this text hello world, and we give it a frame, just a max width infinity, and then a background blue. So now we can see that it stretches if we remove the padding to the entire screen. And if we make this text a little bit longer, just copy this, paste it once again. So by default, this wraps. But if we apply fixed size on the text, this will be wider than the screen. And with the blue background, it's a little bit hard to notice. But if we do a rectangle and say stroke with a line width of 2, we can see clearly now that the edges are beyond the bounds of the screen. Without the fixed size, we would see the edges. Maybe do it in red color so that you can actually see it. So now we can see a little bit of red here. The stroke, I think by default is halfway inside and halfway outside. So maybe stroke border, or actually it should be inside. Okay, so we can see the border now, but the moment we do the fixed size, we don't see the border. And if you are not in control of this view, so if this is, let's say, something that gets passed in from the outside, but you want to make sure that your view always becomes exactly proposed, then you can do something like this. And now we can see that the border is visible again. Let me zoom in. You can actually see that. So we can see the border now. So that means that this frame definitely became exactly proposed, regardless of the size of the contents. And typically, if you leave off the min width parameter, it works exactly as expected, especially if you have like a text like this, or if you have a shorter text with fixed size, it's no problem because it's not wider. Yeah.
So this is perhaps if you're still proposing the entire width of the screen, then it perhaps doesn't matter in some cases if it just overflows because you don't even see it, right? Because it's hidden off the edges. But so one example I just remembered is that we had something with an image grid with square images.
Yes.
And so you create this square proposal basically with let's say an aspect ratio, and then you really want these images to adopt this size, and then you need to make sure that this proposal is really accepted. You don't want either the width or the height to be larger than that. You really want exactly that dimension, and then you can use min width 0, max width infinity, and the same for the height to make sure that this is exactly the size that's being accepted.
Yeah, I think so. This is, let me see if we can put this into the Safari here. Yeah, so I think here is the code for that. This is episode 314, probably inside grid view, right? Here we did this as well.
Yes, there it is.
So the aspect ratio will propose a square aspect ratio, but it doesn't enforce it. So if this view becomes, like if this view has a different aspect ratio, like let's say 16:9, the aspect ratio is not going to modify the result of that view. And so this will make sure that, like here we propose a 1:1 aspect ratio. Here we make sure that it really is exactly the proposal. And then the other view can do what it wants. And
we can apply this clip modifier to this flexible frame that is now guaranteed to be a 1:1 frame.
Yeah.
That's basically what this frame gives us, that we can put this clipped on there.
Yeah, this was
everything that's
some tricky code to write, I remember, but
yes,
it does make sense.
Yeah.
Yeah.
It was also part of one of the exercises we did in a workshop. To do some more of some of the tricky layout parts.
Okay, there's, as far as I can tell, no other questions. Refresh. Okay.
Mostly we also just write max width infinity and it's fine. But there are these rare cases where you really need to say min width 0, max width infinity to get what you want.
Yes.
It's not that common.
Okay, so thanks everybody for the questions today. And yeah, I hope everybody will enjoy the book once it's completely ready, or maybe you're already enjoying it. And yeah, we'll see you some other time.
Let's do that. Bye bye, everybody.
Bye bye.